it's nice to be able to see a variable without any context around it and still know what it belongs to. So I try to be as terse as possible, but also be as specific as possible. So, right, so Pix name and U32 name, right, they both serve the same function, and they're in analogous structures, but I just prefer them to have different names because it's less likely that I'll accidentally. It's less, even though these are analogous, by keeping slightly different names, it just helps me differentiate them a little bit more. And then also, it's less likely that I'll never accidentally, swap a Unipix type with a U32 type because their structures are slightly different with different variable names. So making that mistake will also be less likely. And what was the other thing? Oh, and also when you try to reuse code, right? If you try to reuse code, maybe you'll have less lines of code, and you'll think it's nice because it's so clean and it's concise. But the price you pay for that is more abstraction, and sometimes it's better to be more verbose and have less abstraction just so that you can wrap your mind around what's going on. Because code is already complicated enough, and you don't really want to make it any more complicated than it has to be. So sometimes not using some type of shiny feature will be better than using it just because it's like you can have death by tiny features. You just, oh, this shiny thing, that shiny thing, this shiny thing. And that's kind of why I like C code, because there's only one way to do things in C, because there's not a whole bunch of shiny little features like C++. That makes it easier to read the code, because if there's only one way to do it, then if you see code written a certain way, you kind of more so know what it's doing, because there's only one way to skin a cat, so to speak. What else? So then we have this GPU variable container. I'm not sure if that's the best name for this. But you know what? So this is a class, by the way. This GPU variable container. It's a class. I'm just probably gonna just stick with this because really it's a really this is a controller that's gonna help coordinate getting and setting for these objects here. So this is a procedural approach, right? So I have these struct data here, and then the variable container down here operates on those containers. So this U32 get and the U32 put are basically procedures that operate on this struct data, right? If you wanted to use a more object-oriented approach, then the U32 get and the U32 put function would be put directly into the uni U32 object, right? So we would mix the data and functions together. And same thing with with the get and put functions for the pixel data, for pixput and pixget. Pixput and pixget, we would do the same thing. We would put these functions inside of these structs, right? So it would basically turn these structs into classes, right? And then instead of calling them procedures, the functions, we would call them methods, because methods are functions that belong to objects. Now, you might wonder, well, why did I do it this way? Why did I break things up into this structs and then functions that operate on the structs? Why did I do that instead of just make it into one object? I think part of it was just a personal choice, but it's also, unless I have like a very pressing need to do something in an object-oriented way, like there's some things that are just much easier to do object-oriented, and so it makes sense to do it object-oriented. But unless there is some type of obvious significant benefit where it makes it a lot easier to do an object-oriented approach, I'm going to use a procedural approach, because the procedural approach tends to be more linear, which means it's easier to understand. It's less likely to get tangled spaghetti code. And it's also a little bit easier to avoid dependency loops, because when you divide things up into data and then functions that operate on that data, all you have to do to avoid a dependency loop is make sure that your data is declared before your functions. And as long as you declare all of your data before all of your functions, you'll never get any dependency loops. But when you start mixing objects that contain both functions and data, then it becomes very easy to get dependency loops. And a lot of those dependency loops are just superficial. They only exist as an artifact of the way you structure your code, and there's actually no reason for those dependency loops. So I'm going to try to keep things as simple as possible. Now, simple obviously is subjective, right? Because, you know, I'm sure there's plenty of like assembly code is obviously simple, right? But you wouldn't call it easy, would you? So I'm just explaining, kind of justifying the way I do things. And I feel like I've written enough object-oriented code and enough procedural code that I can kind of mix them together and take the best of worlds and kind of have a I don't know, maybe it's a nuanced approach, I don't know, or maybe it's just a weird-ass approach to how I do this. Okay, so in the next video, instead of ranting, because I think this is the third video I've been ranting for, in the next video, we are actually going to cover me adding more functionality to this code, because we want to, the first thing on my to-do list, I have some to-dos here. Texture creation, texture upload, and then I want the shader to sample from that, and then let's see, updating easily. Oh yeah, and the shader needs to know if it's using that isolated memory block or the main memory. And I want some type of toggle where I can turn that on and off. And that's just a thing I need to do so that it's ready to use for some ideas I have in the future. So yeah, so I'll see you in the next video. Yeah, okay, bye.